That's the benefit of being on the program, I suppose. Nice.
Yeah.
Yeah, do you want to sit?
No.
No? Okay.
I think this is the speaker screen, so.
I mean, we can make it a very communal.
Yeah.
Oh, that's fine. Yeah, no problem. All right.
Great. So do you feel okay to start, or should we wait a bit more?
I think we need a few minutes, but it's okay. If we're going to record it, it's okay. We'll let Vijay know.
Yeah.
Okay.
Quite a few sessions that we need to edit a little still. Start early.
Yeah, fine.
I'm not sure if there's people online actually.
No, here's online. Can you hear us?
Yes, I can hear you perfectly.
Okay, perfect. So just letting you know, we are giving people a few more minutes to drop in and take their seats, and then we can start. Yeah, there are quite a few sessions happening in parallel, so we are fighting for the audience.
That's okay. We're happy to chat with whoever. This is a topic for however many are ready to talk and are available. You can do it.
Yesterday we were just talking about how the coding session, which I think attended, was amazing. How people in the audience were answering questions and sharing ideas.
Yeah.
Very cool.
Yeah, that's really the idea of this OSR.
Correct.
We get this kind of
And
communication.
you may be interested to know, well, I think I've been talking to a lot of faculty at Concordia, Poly, and McGill today, in addition to this. And a lot of them have been talking about similar themes, how to share code. And something interesting that came up is very similar to the conversation we had yesterday is, can we have ChatGPT just modularize the code for us? Can it just clean up the code for us? And, those kinds of things.
Yeah.
And they're asking, is there something is there a Python module that does it? Is there a MATLAB module that does it? Yeah. Having a lot of such conversations, not one or two, but many of them.
Yeah.
So that's the thing, it's like a lot of these conversations happen in parallel, right? Yeah. To have one space where people can actually get together. I mean,
Correct.
Of course, it takes a long time to actually get to any resolution, but
it's good the conversation is happening.
Yeah, it feels that we're sort of transitioning between the initial phase where we had to create recognition for what's necessary.
But the pain is definitely there. A lot of people believe that there's a lot of barriers to sharing.
Yeah. But there are. We were chatting about the barriers as well. I mean, there's a lot of things because different industries and different research fields as well have different requirements, and so it depends what we think the goal of our work is. It doesn't always have to be the code development and cleaning up of the code and all these things. It's kind of often if you have a research question, an accessory or like a tool rather than a goal. So how to negotiate that's a big thing as well.
I think a lot of people don't know that others are facing similar issues. I think it's good when people are talking, they're like, oh, you're also facing similar issues. Okay, it's not unique.
Yeah. I think that it's probably good to get this. No, the other session was starting at 45, right?
Exactly.
Okay, right.
So
it should be a 10-minute talk, I think.
So
right. we can start. Yeah.
Good. So whenever you're ready.
Great. I only have one screen, so I'm going to trust that things are up there. Please speak to me if there's anything that's not working. I'm Vijay. And I'm really glad to be at least remotely with you there in Montreal to take a walk through open science with Mathworks. I'm our principal academic discipline specialist, basically our neuroscience person here at Mathworks. I'm glad that Ram Krishnamurthy is there in the room there with you in the open science room and has been a part of OHBM. There's one thing you have to remember if you want to follow up on any of the things that we discussed today. Remember this neuroscience@mathworks.com, and we can follow up on any of the specific topics. So so we've been, I know we were a part of a panel yesterday, panel 3. We're going to be a part of panel 5 tomorrow, or at least help to kick off that discussion. And I want to zoom back out here. When I look back over the years, I've been working in neuroscience now for over 20 years, with open science being a part of that for at least 20 years. And over those years, I've seen kind of this sequence of steps. This is maybe the steps that I've personally taken, but I also think to some extent it matches the history of the field, which is that there was initially, it goes back 20 plus years, that there's been a fair bit of open code for neuroscience. It's a bit more recent that there's a bit of interest in open, making sure that data is also open, along with, or that there's open, that there's a big push for data in addition to there being like open code tools. That's actually opened the door now. When you have code and data together, I'm seeing a big push, a lot of focus on examples and how quickly they're runnable. And so I think there's a lot to think about in terms of example-based workflows that oftentimes need to combine open code and open data. And as there's been enough data out there, there's been models that have been created from data that can help support analysis of other data. And so OpenAI models have entered the picture. And then as you get data that gets big enough, you start needing to have compute environments that are close to the data, or that are data optimized or cloud optimized. And it becomes important that we have kind of compute environments people can publish and clone and reuse and build upon. And so, now let's think about, so that was speaking in kind of relatively in generalities. Now speaking about it from our company's perspective at Mathworks, with MATLAB and with Mathworks, what I'd like to emphasize is that, we build, and I think we're making a number of different technology building blocks, many of which can serve these workflows, and they come with support. And we want to remind you that there are people that come with the technology and that can support you. In addition, we have folks like myself focused on different disciplines, neuroscience and other scientific disciplines, folks like Ram that are based at different institutes and universities around the world. And we're really starting to coordinate and collaborate more on open science projects. And when we work together, I think we can do things better. So let's take this walk through the down memory lane. Now, it's hard to believe, in the beginning, so to speak, it's been over 20 years now that the File Exchange has been a site for sharing MATLAB code. And if you were to look there today, and so let's actually look there, many of the entries actually are links to GitHub. I think Homer is a good example of this. It's for FNIRS data analysis, and actually, it might not be an example. It's one of the holdouts. Okay, so let's look at Brainstorm being there in McGill. It is a link to the GitHub repository that Brainstorm maintains. So many file exchange, it used to be a hosting site. These days, it's mostly a GitHub repeater, if you will. But it's in addition to just making it findable within MATLAB or just in another place, it actually means that it'll show up in the add-on Explorer, so it can make things easy to install with one click. It also means that it'll get categorized, as I was showing there, so you can actually now search for different neuroscience areas of interest, including human brain mapping and different sub areas of human brain mapping, and find the tools that are interest. So if you make that link, which is set and forget for the authors, it's going to be multiplied in the field. Our team is now, I'm excited. They've recently published best practices for Toolbox authors, which is something we've been talking about doing for years. And I'm glad that we're, best practices are always evolving, but it's good that I think our teams are trying to put out some ideas. We do now have, the cat's out of the bag, a MATLAB Community Toolbox program to work with open code that's kind of tools for others, meant not just the code that you use, but rather code that you've built for others. And for instance, we're running a training program, but we're going to be talking more about that in blog posts to come. And consider this a soft launch, if you will. So what is that MCT program in general? Oftentimes, we're supporting research software engineers or professional programmers to improve open source code. So that's just an example of something that we've been starting to do more of. Okay, so I mentioned open data has kind of come into the picture, and one of the things, like at least from my lens, focusing on open code, I'm seeing some really interesting projects that are basically open code for open data. We can talk about data for itself, which was kind of the topic of yesterday and tomorrow. We have a lot of technology building blocks that I think are relevant for this. File readers, tall arrays, ways to work with remote data, which I think is really important. Data stores, which represent file sets on disk. So I'll share one project that I've been working on. Actually, we're going to do that in the next slide, which is the BIDS toolbox. Now it's very early stage, but I think this link is out of date. So actually, we do want to go back here. Let's just look at the look at it here. It allows it actually reads from, say, OpenNeuro and S3 bucket, uses our S3 functions, and it will create different MATLAB objects, a BIDS dataset object that represents this abstract data set, and then you can have a family of objects that are called BIDS data stores that will represent different participant file sets for specific modalities and stages. And so this is an early stage project that's using a lot of these building blocks, and I think it's an example of how open code can help to serve open data. And then, as I mentioned, when you bring together open code and open data, you can start making examples that pull that open data and have code to process it and really show a complete workflow. And one of the things kind of my reference project for open science has been one that I've been most working on, called the Brain Observatory Toolbox. But we're looking to see these exact same patterns, if you will, in other projects, and many of which are starting to adopt this, including the BIDS Toolbox, which is that examples should be viewable by the public, and they should be runnable by the public, ideally. And that's both possible today. If you link your project to File Exchange, it's viewable by the public. If you link it to MATLAB Online, and we're going to talk more about this, it's runnable. It's in many cases runnable by the public, without needing install, and in many cases without needing a license. And these things which run on MATLAB Online, or at least for the runnable situation, they can actually access remote data from MATLAB Online, and it's pretty fast because it's in many cases, because that happens to be running on Amazon. Many public data sets are on Amazon, like OpenNeuro, for instance. And so if you can use the remote data workflows, it actually runs pretty quickly from browser-based MATLAB, which I didn't actually, I was curious to see how it would work, and I'm really pleased by how snappy it can be. We're working on more open examples. You can see there's a Brain Atlas project. We've been working with the eBrains project in Europe, and they've just added some open examples, and we've been doing the same in cellular neuroscience with the analog of OpenNeuro called Dandy. As I mentioned, OpenAI models are really becoming important, an important part of open science. And a trend we're seeing is that folks may have published an OpenAI model, often in another framework, maybe in TensorFlow, maybe in PyTorch, maybe in Keras, and then they're looking to reach new users and use cases. So they're really actually interested to publish MATLAB code that can work with that OpenAI model, and therefore reach new users and support new workflows. Often they'll publish it again with some sample data so that you can quickly do inference with some of that sample data and really get a feeling for what the model or the model family can do. So this is an example of a project we've been working on called the Sleep Toolbox that works with the sleep models for social animal pose estimation. Another project we're working on is the Deep Interpolation Toolbox for denoising systems neuroscience data. It was mostly tested with animal data, but it has been somewhat tested with MRI data, so it has some human brain mapping potential. In terms of some of the technology building blocks, we now have importers for basically all the most common deep learning frameworks like TensorFlow, Keras, and PyTorch, specific importers for each. In addition to working with the ONNX interoperability framework, we also have a deep learning model hub, which is aggregating a lot of the pre-trained models that we make available to users. But I'm really excited to be working with some of these kind of neuroscience-specific open AI models and really showing what our deep learning toolbox framework can do. And then last but not least, in terms of this walk, I want to talk about the notion of open compute environments. And one of the projects I'm really excited about is this, is really setting up tailored environments that are geared towards a set of users. In this case, it's for cellular and systems neuroscience. which is a Dandy Hub, which works with the Dandy Data Archive, again, the analog to the Open Neuro Data Archive. And so what would a configured compute environment look like? Well, it should maybe have MATLAB pre-installed, maybe with the relevant Mathworks products, not all of the 80 toolboxes, but maybe the ones that are most relevant for this set of neuroscientists, then have the community toolboxes that are relevant to the category, kind of coming back to that notion of different categories of neuroscience that we can see sort of laid out on the file exchange, have the relevant open data mounted right there near the compute, maybe have some of the relevant open AI models available for training. We're working on getting sort of GPU access. So how did this actually work? It actually used our MATLAB integration for Jupyter. So that was a technology building block. Other people can make their own container images outside the Jupyter environment. We can also do this, outside of a container if you want to just spin up an AMI. And so I've been working also on a MATLAB for neuroscience reference architecture for AWS. So kind of after you've maybe done some exploratory research in one of these open compute services, you might go ahead and spin up your own AMI once you're ready to sort of do your PhD project after your exploratory work. And some of these reference architectures can be a jumping off point for getting your compute environment set up. So this is kind of a list. I was kind of looking through a kind of all the different sort of technology building blocks that you can find on our doc pages or our web pages or our GitHub pages and other reference architectures. And so these are, there's a lot of building blocks there. And I want to emphasize again that all of this comes with support. So, you can find these things on our web pages and ask someone about them. And we think this can help a lot of open science projects. Okay, so we have a big announcement in the last week. Our MATLAB blogger, Mike Croucher, one of the research software engineers in the UK, had joined Mathworks recently, and he had the pleasure to make this announcement that that for the last, actually it's been in stealth mode now for, if you will, six or so months, I would say, that there's a MATLAB online tier that's publicly available, so that in many cases, if you set up your example, for instance, or your code, your toolbox to run in MATLAB online, in many cases it'll work publicly for folks that don't have a license, at least for a certain number of hours, right? So an example now that's sort of got this workflow going is my reference project, the Brain Observatory Toolbox. Again, it's globally viewable, it's globally runnable, it has global, since it's using AWS, which has a global network, it has global cloud native remote data access. So I'm really excited about some of the new possibilities that are really opening up. So to recap, a lot of this is powered by our MATLAB Community Toolbox program, which is a growing effort at Mathworks. But to recap, it's a combination of more technology building blocks for toolbox developers, but also for a lot of other open science aspects. And there's a growing number of folks at Mathworks like myself, Ram, and others that are really excited to collaborate with your open science project. So consider using our building blocks as a starting point. Utilize our tech support. Be in touch with the folks at Mathworks that are related to your, that connect to your location and to your domain. And we'd love to hear your ideas for enhancements that we could, what are our next generation building blocks? Again, neuroscience@mathworks.com. It's been my pleasure to share this walk with you, and I'm available for questions. So I'll turn this off and get back to the other screen. Go there. Thank you. I don't know why I lost the stop sharing. How do I get there? Let's see. Where's my crowdcast? There you are.
All right.
Excellent. Happy to take questions.
Right. Any questions from? I actually have a question that's something that's I was always wondering. I'm somebody who has been using MATLAB a long time, even before I started using Python, etc. And I've always been wondering, and what I like about MATLAB is just the sheer fact that I trust it, and I've not always had the same kind of trust in public code. So is this something that MATLAB is also capitalizing on? In what way does Mathworks see itself differentiate or put itself as a competition against like all of these new like community efforts that are built and now apparently are used as like the ways with which science is done, where classically math was or Mathematica were the programs that were used.
Yeah, great question. I mean, I think the question of why someone might have MATLAB versus Python versus another language as their home base, so to speak. Gosh, everyone. I mean, I have some of my own personal answers. I'm a real big fan of certain aspects of the MATLAB language, but what I've realized from talking to lots of people is everyone has different answers. Maybe some of the most popular are the documentation. So, sometimes people really like the strongly integrated environment, the fact that the releases come out and everything is tested against each other. Certainly, we build some core components that are general. We don't, make a lot of stuff that's going to be very specific for neuroscience. We have a nifty reader now, an EDF reader, but generally a lot of the stuff that we build is going to be general, but it's all very tested at every release. And so a lot of people, and that's just part of our, and it's probably at a standard that actually I wouldn't encourage even many community projects to go to the same standard, because science is meant to go really fast or to push the frontiers. And we're obviously, we have a higher weight on quality and testing, and that's probably the way it should be, right? Whether that's, the differentiator or the reason to choose this at the home base. I mean, these are very individual decisions, but we really want to support our users and use cases, and we really know that we need to reach out into different fields, and that's why we're excited to also collaborate with the community projects that may have less of a, not the exact same standard or a big testing cluster that's focused on hundreds and hundreds of unit tests, but they're also really important to driving science forward, and they're all a part of accelerating science. So we see it as kind of, I see it personally as kind of a mix of a really solid, heavily tested core together with some really strong collaborations on the edge for specific fields.
Yeah, that's for me, at least personally, always something that has been super important. The idea that everything has been thoroughly tested in a way that you can not really expect, at least not generally by communities to happen. What we do see though is that within the community, there's an increasing appreciation of testing your code, right, and ensuring quality and those kind of things. So I wonder if Mathworks has plans to sort of get that expertise into unit testing as becoming a key feature of the Mathworks environment, right? So that's something that it seems to be not necessarily present within all the different like flavors of code that you see out there now.
Yeah, so there is a unit testing framework within MATLAB these days. So I mean, actually, one of the things I'm pleased is we're starting to break out. They kind of reorganized how we've set up our MATLAB What's New page, where it's broken down by sort of the low code stuff, and then the developer workflows, and then things like Python interoperability and graphics and data analysis. And in terms of the developer workflows, you can read about some of the developments in terms of unit testing. Actually, but one of the things, so there is actually a pretty complete unit testing framework, and certainly for the folks that want to do that, I know projects like EEG Lab, they've been doing some degree of unit testing for years. They just had a chance to experiment with their unit testing framework in one of our community toolbox projects. Excuse me, and they may adopt that more. At the same time, actually, I'm really excited about a project that's coming out soon, which is because I think more researchers are likely to maybe make examples that are maybe formally, we might call them integration tests or smoke tests, that they probably get a good deal of coverage of exercising the code base. They may not do it to the same degree or granularity that a unit test would, but they still add a level of testing, and they kind of serve a documentation purpose. So it's sort of doing double duty. And one of the things, the team that's made the best practices and is trying to service community developers is built as a bridge between, it's built kind of a smoke testing tool that's a bridge between, say, the live scripts and the unit testing framework. So folks don't have to know the details of the unit testing framework, which is kind of heavyweight for the average scientist per se, but still could have some degree of example-based testing. So that's coming out soon. So yeah, we do enable, and to the right degree for every individual project, encourage community developers to do testing. And of course, I'd love to get more feedback on it if you test out the testing and tell us how well it works for you.
Hey, can I add to what Vijay said? I think I really like your question. I think because what can we do? We, of course, test. We do a lot of things to test. Like we have internal math workers who actually bash the code before it's released every 6 months. So when it goes out, it goes out in tip-top shape, and we make sure it's backward compatible, so on and so forth. And I think you'll also notice, and I'll give you a little bit of industry, academia, commercial perspective too. And you'll definitely see a lot of use of tools like MATLAB Simulink, especially when we talk about aero, defense, CES, electronics, the Teslas we drive, we see. You're going to see a lot of it used because they don't need to worry about additional testing, worrying about the platform. It just works. You don't need to worry about bringing in from different platforms and getting it to work. You can trust the result you're getting. So for those reasons, you definitely see it. Even in research, you're going to see that for those, like a lot of times when I speak to someone who's working with the DOD, the Defense Department, it's a de facto they're going to use. And that's kind of how we have like 5 million users or whatever that big number is. Yeah. Having said that, I think there are a few nice differentiators that I've seen a lot being used that I know for a fact that have not yet been in, forget Python, but other languages like even C, C++, Java, whatever we're talking about. I think one of them is the fact that you can translate and generate code. So you can do your prototyping in MATLAB. But then if you want, like a faculty I was working with, they worked on source separation for hearing. And they have developed this code in MATLAB, but they want to put it onto a hearing aid. So they need it in C, C++ or an embedded system. Are you going to rewrite all the code in C, C++? That's a big challenge. But we have these tools that automatically convert your code from MATLAB to C, to CUDA, to Verilog, those kinds of platforms, to DSP. And this is a big, not just a revenue generator, but also a big selling point for a lot of people because you can do what you like in your language. And the second thing is the interoperability. We definitely recognize it's not just Python. There was Java before, there was Fortran before. They always exist. But a lot of people have learned programming in MATLAB, and they want to extend what they can do, maybe to other languages. And that is where the ability for you to be able to call MATLAB code in Python code back in MATLAB. And there are going to be a lot of people who are going to use these, who like using such workflows. And those kinds of things kind of gel the entire workflow. Like if it's data analysis, all the way from pre-processing to deploying. It's sometimes very hard to do the entire thing in a language like Python. But that's where you have these nuggets that come in, like you can do with MATLAB, and then you complete the entire workflow. Yeah. There are a few things like that.
Thanks. That was my question. I'm not sure if anybody else has a question. We only have a very brief session because it's impromptu. If not, then of course. I would say thank you so much for joining us. And thank you also, Ram.
Sure. Thank you.
And
Thank you for organizing this. It was great to have a chance to chat with folks.
Yeah, absolutely.
It's also recorded, so it should be online if we stop editing the last bit. So.
Yes.
Yep.
It might take us a few weeks / months, but we'll upload it on our YouTube channel as well, so people can rewatch it in the future.
Looking forward to looking back at it.
Thank you.
Wonderful.
Cheers.
Thank you so much. Yeah.
Bye-bye.
Goodbye.